As we work our way through this unit on triangle congruence, we are now at the point where we're giving you some examples, doing a proof here on proving that two right triangles are congruent, and we'll be using the HL theorem to do that. So we are given that BE will bisect AD. So BE rather, is this line, and it's bisecting AD at C. So I'm going to put a little dot there. That's our midpoint. Also, we know that AB and BC are congruent. AB and BC are congruent, so there's a 90-degree mark there. DE and EC are congruent, so there's a 90-degree mark right there. And AB is congruent to DE, so AB is congruent to DE. Can we prove the two triangles are congruent? Well, obviously the answer is going to be yes. So let's do it. Let's figure it out. So I actually wrote down all the given information already, and I wrote given over here. You have to put the given information in as your first steps, and then just write given. So that's not too bad. Now, let's talk about this. These are right triangles, so we can use HL. So I have to check the hypotenuse to see if it's congruent, and it doesn't say it's congruent. This is the hypotenuse of this triangle, and that's the hypotenuse of that triangle. It doesn't say they're congruent. So far right now, I haven't shown that they're congruent, but I do have a pair of legs. So I have the L part of HL. I just got to figure out where the H part is. So can I somehow prove that the triangles are congruent using the HL postulate? So let's take a look here. So I've got this given information down, but I also know that AC is congruent to CD. Now, how do I know that? Well, it's because BE bisects AD at C. So that makes this a midpoint of this segment. So if that's in the middle, then this segment and that segment have to be the same. So I'm going to write down AC is congruent to CD. Now, what would I write for my reason? Well, it's actually the definition of bisect. I mean, what does it mean to bisect? It means to put into two congruent pieces. So we are defining bisect. We're saying those two sides are congruent. So now I know that I have H, right? But here's the problem. I don't really know yet that these are right triangles. I know, that sounds kind of funny, but how do I know that these aren't technically right triangles? It didn't say these were right triangles. Okay, this is kind of a strange point, but you have to be very, very precise when you're doing these proofs. So it didn't say these were right triangles. It only said that the segments were perpendicular. So what I'm going to have to do in the proof is say angle B and angle B and angle E are right angles. Now, I can say that because that's the definition of perpendicular. Because those are perpendicular, now I can say those are right angles. Okay? And now that's a right triangle, and I have H and I have L, so now I can say triangle ABC is congruent to triangle DEC because of HL. It is important that you write this down for the precision of the proof. So there it is. We've proved that those two triangles, those two right triangles, are congruent according to the HL theorem.